413 is another video I'm super hesitant to make, and it will be a lot more jumping around, I fear. So upper and lower bounds. Today we'll think about everything you know so far about statistical analyses, and we'll write a report with all these elements. Then you will learn how you can report a range of values for your predictions. So in 1997, an anthropologist discovered an early humanoid in Europe. As part of the analysis of the specimen, the anthropologist needed to determine the approximate height of this humanoid. The skeletal remains were highly limited, with only an ulna, which is like a forearm, being complete. The bone measured 26.4 centimeters in length. Consider how you could determine how tall the humanoid was. Discuss the question below with your team. Be ready to share your responses with the class. So what information should we gather to answer this question? What process can we use to gather this information? And what statistical information can we report back to the anthropologist? So once your class has decided what elements your report should contain, collect and analyze data with your team. Write a few sentences to the anthropologist explaining your findings. So what happens at this point is I pose it to the class, and usually they come up with the idea, why don't we measure our forearms, and then we will measure our heights, and we'll compare the two together, and then we can use that as come up with a prediction line and plug 26.4 into our prediction line and guess how tall the humanoid would be, and that's what we're going to do. But obviously, I don't really have the opportunity to do that, of course. So what I'm going to do is I'm going to go with the books. Actually, the book has some data that I'm going to use. So this is the data that I have. I went into Desmos, I put this in a table, and I've gone over here, and this is where I'll use my best fit line on, and we'll talk about some problems and some limitations that we have with this data, or at least with this graph, that aren't always super obvious just from glancing at it at the beginning. So again, quite a bit of bouncing around. So once your class has decided what elements your report should contain, collect and analyze the data with your team. Write a few sentences to the anthropologist explaining your findings. So because the height you found for the humanoid is a prediction, so we need to go through this whole thing. So we have this data here. I'm going to go ahead, I'm going to draw a line of best fit, at least what I consider to be a decent line of best fit. Again, your line of best fit would be different. So a couple of points I want to make. First of all, and sometimes kids pick up on this and sometimes they don't, this is not my y-intercept. This is just 16 right here, right? So this is the length of the forearm in centimeters, and this is our height in centimeters. Well, you can see that the graph is broken, so my y-intercept isn't going to work. So I need to do just by looking at the graph. So I need some lattice points. That's not a perfect lattice point, but it looks like 30 and 190. So I have a decent one on the right side. Let's see if I can come up with one on the left side. Again, I want to be as far to the left as I can. That's not a great one either, but so that looks like 19 and 110, 120, 130. So it's not perfect, but it's okay. So a couple of things that I'm going to do here. I can figure out my slope, which is, of course, change in y over change in x. So I'm going up 60, and I'm going over 11. So I'll grab my calculator, and I will say 60 over 11 is going to equal 5.45 repeating. Okay, well, what's my y-intercept? Again, I can't just go here, so I'm going to use that old strategy we used from like chapter 2, I think, where we have y equals mx plus b, and it doesn't matter which x and y I use. I'll just use these ones because they're smaller, but I will plug 130 in for the y. I'll plug 5.45 in for the m. I'll plug 19 in for the x, and then I will solve for the b. So hopefully you guys remember doing this earlier in the year, and it's not such a big leap for you. But so we're going to say 5.45 times 19 is going to equal 103.55. So 103.55. So 130 equals 103.55 plus b. I'll subtract 103.55, and I'm going to get a y-intercept of 130 minus, and I can just put minus the answer You can see that ANS, it'll just plug that 103.55 in. So I get 26.45. So again, I hope you understand how we got this number, and we didn't just pick like 115. A lot of kids would just pick 115 here, but that's not where x equals 0. X equals 0 is way over here at 26.45. So our equation is going to be y equals 5.45x over 1 plus 26.45. And again, in context, what does this mean? Well, let's go ahead and talk about what these mean in context. This means 5.45 y's, which are height. So I get, let me clear this, so we'll say 5.45. So this is the meaning. 5.45 centimeters of height for every 1 centimeter of forearm length. So as your forearm grows a centimeter, you should get 5.45 centimeters taller. And our y-intercept says that if you had 0 centimeter forearm, that you would be 26.45 centimeters tall. So that's what our slope and our y-intercept mean in context. So if we guessed that the humanoid was, I forget, was he 26 so we're asked to predict 26.4. So again, we can use two things. If he's 26.4, he's going to be right around here. So our prediction line is going to be right around 170. So our graph prediction, and again, our graph prediction doesn't really matter because I'm going to end up going with the equation prediction anyways. And then I can just plug 26.4 in to the equation. So again, it's 5.45. I'll just throw a couple extra 4 5s if you remember it was repeating, times 26.4. And then I will add 26.45. And we get 170 again. So our graph and equation prediction was 170 centimeters. So pretty good. So we would report back to the scientists that we think that the humanoid is 170 centimeters tall. But we run into a problem. It says because the height you found for the humanoid is a prediction, the actual height in the early humanoid was probably a little shorter or a little taller. In this problem, you're going to investigate how you can report a range of values. So we're going to look at the upper and lower bounds, which is going to be what's the most it could possibly be within reason and what's the lowest it could possibly be within reason, the upper bound and the lower bound. And we would expect it to be somewhere in these bounds. So what we're going to do is we're going to make a residual, the biggest absolute value residual. So the biggest absolute value residual is going to be how much I miss by, again, at the most. So you can see this residual is not very big. This residual is not very big. This residual is decent size. This might be the one. Not very big. So this one missed by almost 2. This one missed by less than 2. So no. That's a little more than 1. So I think this is our biggest miss. This one right here. So this piece of data. And again, our prediction was 170. So we don't need all this. So our predicted height was 26.4 and 170. That was our prediction. So what is our biggest miss? Our biggest miss was at 24. So if we go back over to the data, we can see that 24, the actual was 175. So this is 24, 175. This data point right here is 24, 175. What was our prediction at 24? It looks like it was a little bit below 160, right? So let's go here and let's figure out what our prediction was at 24. So 5.45, again, it was repeating, so I'll just throw a couple in there, times 24 plus 26.45. Our prediction was 157. So our actual of 175 minus our prediction of, I've already forgotten, 157 gives us our residual. So you can see our residual in this case is a positive 18. So the most I would expect to miss by is 18, right? Well, what I'm going to do is I'm going to use that residual to the positive and to the negative, and what that's going to allow me to do is come up with a range. So again, I'm going to use a positive residual of 18, and it's easier than it looks. So I'm just going to go over here and I'm going to add about 18. So that's roughly 2 of these, right? So if I'm right here, I'm going to add 1 and 2, a little bit less than that. As a matter of fact, I'm going to change the colors here. Here, I'll add a little bit less than 2. So 1, 2, a little bit less than 2. And then here, I'll add a little bit less than 2. So I can go ahead and draw a straight line. So you can see my points weren't perfect, but that's okay. On the bottom, I'm going to go a little bit less than 2. So there's 1, 2, a little bit less than 2 will be right there. Go to the middle, a little bit less than 2, probably about right there. And a little bit less than 2, probably about right there. Again, I will draw a straight line, and we will see that I have these boundaries now. So this is my upper boundary, and this is my lower boundary. So the question would be, well, what are the equations of those lines? And you might think that the equations are difficult, but they're really not. We already have, so think about it, we already have our equation as y equals 5.45 repeating x plus 26.45. So my upper boundary has the same equation, y equals 5.45x. And I'm just going to add 18 to the y-intercept. Didn't I just go up 18? So 3444.45. And then my lower boundary, again, is going to be the same equation. But on this one, I subtracted 18, so I'm going to have a y-intercept of 8.45. So now what does this mean? Well, if my early humanoid was somewhere between 26.4, so I expect them to be somewhere on this graph, right? We already said our prediction is 170. Well, my upper boundary prediction looks like it's, what, a little bit below 190. So, but I'm just going to add 18, right? My upper boundary prediction, I'm just adding 18, and I'm going 188. And my lower boundary prediction, again, if we look here, it's a little bit above 150, but I'm just going to subtract 18, and I get 152. So our report would say, all right, well, we expect him to be 170 centimeters, but it wouldn't be shocking if he was as tall as 188 centimeters, and it wouldn't be shocking if he was as short as 152 centimeters. If it fell, outside of that range, we might rethink and draw new upper and lower boundaries, but this is our guess. 170 is our guess, but as high as 188 and as low as 152. And again, we use the biggest residual to the top and to the bottom was how we calculated that. So running back over here, with their team discuss the bounds of the data. So we already did. So that's 413 in a nutshell. Again, hopefully you guys are okay with that. The interesting thing with upper and lower bounds is you would think this is super important, and we're going to talk about upper and lower bounds for the rest of the chapter, but we really don't discuss them. They show up a little bit in the homework, and that's about it.